Once again, good day. This time, I'm going to give you another type of connections in sequential control. Now, we will be using timer this time instead of push button. Meaning, you can press only once. Then, you have to wait the predetermined time. Then, the next motor will run after the first motor. Okay? Now, in the previous videos, I told you, you are going to use two push button, start and stop. But, motor number 2 is dependent from number 1. The problem there is that motor number 2 will only run when motor number 1 is energized. Okay? Meaning, if you will immediately switch on the push button number 2, meaning the start button intended for motor number 2, without running first the motor number 1, motor number 2 will not run. So what you will do? You have to switch on first, or run first the motor number 1, then that's the time that you will switch on motor number 2 by pressing the second push button start. But this video now, I'm going to explain to you, and as well as the diagram, using OnDelay timer. Now remember, we are using a time delay relay here. And then, what type of time delay relay? OnDelay. Now, I already explained it to you, the principle of this timer. So, the condition is like this. Motor number 2 will only run after 5 minutes when motor number 1 is running. Meaning, I will press the button start, motor number 1 will run. Then if the predetermined time for the motor number 2 is, let us say, 5 minutes, then we have to wait 5 minutes. So motor number 1 is running, wait for 5 minutes, then after 5 minutes, automatically motor number 2 will run. Okay? That's the condition. Again, motor number 2 is dependent to number 1. But this time, you will only press start button once. Not like in the previous one. Diba? So, the power circuit, the same. Or the magnetic across the line. You just simply connect the two magnetic across the line power circuit in parallel. Then that would be the power circuit of this connection. So, you have here. Now, by the way, I will give you some review on OnDelay timer. Maybe you forgot it, no? So you have here the holding coil of your timer. So we place here TR, and then you have your timing contact. Okay, like that. So this is your common terminal. This one. This is your normally closed, and this is your normally open. Now remember, this is your timing contact. Remember, this is your timing contact. Meaning to say, there is a timer there. Meaning, if I'm going to set 5 minutes, okay, I will energize the timer, meaning the holding coil. Now, the holding coil is already energized. Then after 5 minutes, this contact will transfer here. So there is a delay. There is an on delay. Okay? That is it. Now, How about if you will connect it? What is now the control circuit? So you have here the control circuit. Again, you have overload contact. Now, considering that you have two motors, then each motor is protected by overload. So you put another overload contact. Okay, so this is your OLC1 and this is your OLC2. Then you have your push button stop or off button. That's it. Then you have your start button. Start button here, like that. Then you have your maintaining contact, and you have your holding coil or magnetic coil for magnetic starter number 1 intended for motor number 1. So this is coming from number 1. This one. Okay. Now, how about the timer? The timer holding coil or magnetic coil is already connected parallel to the holding coil of your magnetic starter number 1. So this is your TR. So look at this. You set 5 minutes, diba? So what you will do when this one is already energized, this will also energize at the same time. Now, how about the main contacts? So you have your maintaining contact here, and then you will only be using this contact. You have your holding coil for number 2. Then connect that in parallel. Okay. So that is it. Look at that, huh? So when I press the button here, this will energize. So motor number 1 is running. And at the same time, the TR here coil is also energized. Since this is going to be to run number 2 after 5 minutes, so you have to wait for 5 minutes. So after 5 minutes, this contact will transfer here. Bang. So motor number 2 now is running. Okay? I hope you get that. Huh? Again, like this. I press the button here. Motor holding coil number 1 is energized. At the same time, the magnetic or the holding coil of your timer is also energized. Since this is adjusted to 5 minutes, after 5 minutes, motor number 2 will run, then we have to wait 5 minutes until this contact will transfer here. So after 5 minutes, contact transfer here, then this coil is also energized. So motor number 2 is energized. So if you will switch off, both of them are off. Now if there is trouble in motor number 2, this will open. If there is overload in number 1, this will open. So both of them are open or disconnected from the circuit, but only one of the two motors is defective. Okay, so again, you locate the trouble. So that is it by using this. Diba? Very simple. Now, sometimes we need to preserve the TR or the timer. Because if the motor is 24 hours to run 24 hours, then of course the TR is also connected 24 hours. But we need to preserve the life of your timer. So how would you do it? This time, we will add some auxiliary contacts, normally open and normally closed, just to disconnect the timer when motor number 2 is energized. Okay? So what you will do? So what I'm going to do here, I will place an normally closed contact here, TR, coming from number 2. Like that. Number 2. Meaning to say, when this contact here transfer this energized magnetic coil number 2. So when this is energized, since the normally closed is taken from magnetic contactor number 2, so what will happen to this? This will open. So meaning this disconnects the TR from the circuit when this is energized. So once that is energized, what will happen to the contact here? It will go back to normal position. And then the cooling coil is de-energized, therefore the motor number 2 will not run. So we are not meeting the condition. So what you will do to maintain the flow of current here, to maintain the operation of motor number 2, even the timer is already disconnected, what you will do there is you have to place here a maintaining contact coming from number 2. So when this is energized, this will open. So this is disconnected from the circuit. And then this will close. Okay? This is already closed because of this timing contact. Now remember, when the holding coil is disconnected from the circuit, the timing contact will go back to its normal position. So no more contact from here to here because the contact is in normal position. Why? Because this is disconnected from the circuit. Why? Because number 2 is already energized. That is it. So this is now the second diagram, no? Preserving the life of your TR. But the first one is still correct. But only if the motor will run for 24 hours, then this time you have to preserve the life of your timer by adding normally open here. Okay? By adding normally open and then by having normally close here. That is why when you are using a magnetic contactor and then this is your diagram, see to it that you have normally closed and normally open auxiliary contacts of both contactors. So I hope it is very clear. Okay? So this is now the circuit using timers. Okay, this time I will give you another diagram. This is what we call a continuation. What if there are 3 motors that you need to control? The condition is like this. Motor number 3 will not run, not unless you will run number 2. Then number 2 will not run unless you will not run number 1. Meaning to say, number 2 is dependent to number 1. Then number 3 is dependent to number 2 and number 1. Now, in the first diagram, I'm going to give you using push button. Okay? Each of the motor. So therefore, there are 3 magnetic across the line power circuit. Then you connect that in parallel. And then each of the motor is being protected again by overload relay. Okay? So here it is. Again, look at the condition. Remember the condition. So you have your push button, overload contact here. So therefore, you have already 3 overload contact. So you have OL1, OL2, OLT. 3. OLC1, OLC2, and OLC3. Okay. Then, what is the purpose of this OL here? When one of the motors, of the 3 motors, one of them is defective, then all of them will be removed from the circuit, but only one is defective. So either of the 3. Number 1 is defective, everything is off. Number 2 is defective, everything is off. Number 3 is defective, everything is off. But only one is defective. So you have here your circuit number 1. Then you have your start button. Then you have motor or holding coil number 1. Like that. So this is coming from number 1. Now number 2 will be like this. Okay. Then you have your start button. You have your maintaining contact coming from number 2. This time you will place and normally open coming from number 1. Then this is your number 2. Okay? Now how about number 3? So you have here start button number 3, start button number 3. Then you have your maintaining contact here coming from number 3. Then you have your normally open coming from number 2. Then you have your holding coil here for number 3. Then connect this in parallel. So that would be the connection. So look at this. Again, if one motor is defective, let us say number 2, this will open. So once this will open, of course, everything is off. The same with number 1 and number 3. Now, if I'm going to press immediately number 2 without pressing number 1, so what will happen? It will not run. So you press this button here, this contact here, but this is still open because this one is coming from here. So you need to close this actually contact normally open by energizing number 1. So once you energize this, this will close. Then you press the button, energize. So once this is energized, this will close. Then press the button. Okay? So meaning to say number 2 is dependent on number 1, then number 3 is dependent on number 2 and number 1. So you cannot connect directly the number 2 and number 3 without, again, pressing the number 1 first or running the number 1 first. Number 3 will not run if number 1 and number 2 is not energized. So that is the sequential control using a push button. Okay? Then you have 3 power circuits. Individual power circuit of magnetic resistor line, you connect it in parallel. It might be single phase or it might be a 3-phase. Okay? Now, another one, look at the contact. Look at the connections. Okay. Now, how about if I'm going to use timer? So this time, I will be using timer. Maybe the condition, motor number 1 will be energized. Then after 5 minutes, motor number 2 will energize. After 5 minutes, motor number 3 will energize. So 5 minutes gap. Okay? So you have here. This time you will be using 2 timers. Don't even forget here. You have your overload contact here, like that. Then you have only 1 push button stop. Then you have 1 push button start. Then this is your holding coil number 1 for magnetic starter number 1 intended for motor number 1. Then you have your maintaining contact here coming from number 1. Okay? Now, this time you have to connect timer number 1, T1, parallel to number 1 motor. Then you have your timing contact here, TC1. Meaning to say timing contact number 1 is coming from timer 1. Then you have your motor number or holding coil number 2 to control motor number 1. Okay? Then you also connect here T2. And then you have your timing contact number 2. And then you have your motor number 3. Okay, so this one is number 2. 1, 2, and 3. Okay? Then you connect this in parallel. Okay? So look at this. There will be 5 minutes gap here. There is also another 5 minutes. Meaning to say, after running number 1, you wait 5 minutes. After running number 2, you wait 5 minutes. Then the motor number 2 will run. Okay? So, how will you do it? press this start button. Motor number 1 is energized because this is energized. At the same time, timer 1 is energized. Wait 5 minutes. After 5 minutes, this one will energize or contact. Then motor number 2 is running together with timer 3 holding coil. Then you need to wait again 5 minutes. After 5 minutes, this contact will transfer it. Then all of them are already running. Okay? Using an on-delay timer. Oh, look at that. Okay? Okay, so my after this, I'm going to give you a quiz for this video. Your quiz will be like this. Listen carefully. Your quiz will be like this. You draw a control circuit. You draw a control circuit. No? Draw a control circuit. No? Then, after 5 minutes, motor number 2 will run, but disconnecting the timer number 1. After 5 minutes, motor number 3 will run, but disconnecting the holding coil number 2 of your timer. But all of them are running. That's the condition. Okay? Again, you press the button number 1, motor number 1 will run. Energize number 2. I mean timer number 1. Then after 5 minutes, number 2 will run. Okay? But disconnecting timer number 1. After 5 minutes, number 3 is energized. At the same time, disconnecting number 3 or rather timer number 2. Okay? Meaning to say, we are preserving the timers when all the motors are running. Now, I give you a sample. So, let us find out if you can pass. You pass it by group. So, just review the video. Okay? So, that is what we call a sequential control. This time, you are using timers, then 2 timers. So, I hope it is understood. So, what you will do, just review your videos, keep on reviewing until such time that makuha na ginimutan natin. Then, of course, another one here is that try to brainstorm with your group with this. And if you have some clarification, you can ask your questions and then through our group chat. Then your answer of your quiz will be sent to message request, not in the group chat. So this is true with all the classes, no, taking industrial motor control, including the masteral. So please feel free to view our videos. And don't forget to like, subscribe, and share. Thank you and good day.